ESA's mission to Mercury has started its long test campaign. The European Mercury planetary orbiter feels the heat of the Sun for the first time in ESA's large space simulator at ESTEC in the Netherlands. As Mercury is the closest planet to the Sun, the BepiColumbo orbiter will have to withstand the heat of solar thermal fluxes that reach a temperature of 450 degrees centigrade. But that's not all.
It is not only the Sun that delivers an enormous thermal flux into the spacecraft. On top of that, we fly over the surface area at very close distance. And Mercury is like a very hot stove that puts thermal load into the spacecraft as well. So we are like in a sandwich, in a squeeze between the Sun and Mercury, receiving very high temperature from both sides.
And adding to this will be the heat produced by the spacecraft itself. As insulation from the external heat, the orbiter will be wrapped in a double layer. Firstly, of ceramic material used for firemen's jackets, and secondly, of layers of wafer-thin metallic insulation. This protects the spacecraft's electronics, which need to remain at around 20 to 40 degrees. And to cover the entire side of the spacecraft facing Mercury, ESA has designed a sophisticated radiator with a Venetian blind system. This will deflect the heat from the planet, while at the same time allowing the heat generated by the spacecraft itself to dissipate into space. The orbiter has spent the last 3 weeks being thoroughly tested in ESTEC's space simulator, the biggest in Europe, which has been specially modified to simulate the intense heat and harsh environments surrounding Mercury.
The performance of the spacecraft was very well. The radiator behaved exactly as expected. Also, the performance of the multi-layer insulation was as expected. We have, on top of that, identified a few heat leaks that will now allow us to, in fact, design a few modifications. But this is exactly why we do such an important test. And overall, I regard these test results as very positive.
To ensure the greatest chances of success, over the next months, BepiColumbo will go through further mechanical tests before being integrated with Japan's Mercury magnetospheric orbiter, its sun shield and the transfer module. These components will together form one single composite spacecraft for the duration of the journey to Mercury. On arrival, the spacecraft will separate into 2 separate orbiters that will work hand in hand around Mercury. This teamwork will bring us significantly closer to understanding the formation of the entire solar system.
It's important to study the whole spectrum of the planet, the one far from the Sun and the ones closest to the Sun. It's very important to study Mercury in order to get the full picture and to better understand the formation of the solar system.
BepiColumbo will be following in the path of the only 2 missions that have visited Mercury to date, NASA's Mariner 10 and Messenger. These left behind some mysteries that BepiColumbo hopes to unravel. For instance, the high density of the planet and the newly discovered more volatile composition of the surface, which may suggest that Mercury was formed further out in the solar system and then displaced.
If you really want to understand what's going on, the features on the planet, the material, it's essential that you go there and do some measurement in an orbit around the planet.
Presently, NASA's Messenger mission is in orbit around Mercury. One of the mysteries that it's observed are bright blue-white spots that can be seen over the entire surface of the planet. But as Messenger's elliptical orbit only allows high-definition observation of the northern part of the planet, these remain unexplained.
It would be very interesting to find out what is the material of these bright features. With BepiColumbo, we are able to have a resolution of a couple of hundred or kilometers and a much finer instrumentation, a higher resolution.
The fact that BepiColumbo is in a much closer orbit around Mercury and its improved instruments should help it to answer many of these questions. For every ESA mission, new technologies have to be invented. In the case of BepiColumbo, its projected 6-year journey has prompted the development of an ion propulsion system. This system, using ionized xenon gas, will allow the spacecraft to make large velocity changes using less fuel for prolonged periods of time. So as with most ESA space exploration missions, BepiColumbo will drive technologies that will no doubt find other applications while fulfilling its intended role in further investigating the mysteries of our solar system.